Hi, everyone. I'm Aaron Larson, executive editor of Power Magazine, and you're listening to the Power Podcast. On today's episode, I'm joined by three experts from Mechanical Dynamics and Analysis, or MD&A. With me, I have Dave Fernandes, who is Gas Turbine Program Manager. I have Jason Wheeler, Gas Turbine Rotor Repairs General Manager, and Kevin Roy, who is a Principal Engineer for Parts. And to kind of kick things off, I want to give a little bit of background on MD&A. MD&A was first founded in 1982 as kind of a small team of very experienced engineers that worked on vibrational issues and alignment issues and component repair recommendations. And then by the mid-90s, when deregulation had kind of changed the landscape for power, MD&A evolved and kind of expanded its capabilities by establishing shops in St. Louis, Missouri to handle steam turbine and generator repairs. And also on-site labor groups and tooling sets were added to help customers execute outages. And now you've expanded into gas turbines. So Dave, can you explain how that came about and why the company has focused so keenly on the 7FA model in particular?
So early in the 2010s, I'll call it, a strategic direction was decided by the CEO at that time, which was John Vanderhoef, to really start focusing on getting in the gas turbine business. So that's gas turbines in general. The 7FA, particularly, it was the core model that was sold domestically during what is often referenced as the gas turbine bubble, which was from 2000 to 2004. There was between 600 and 700 of these that were sold just in that time frame. So when you want to get into a new industry, you focus on what investment to make based on what opportunities are out there. And the 7FA and additionally the 7EA were the two units of focus based on the sheer number of opportunities out there based on the unit counts.
I'd like to go a little bit deeper into that. Do you feel that there was anything lacking in GE's capabilities to service these units, or was it just a numbers game where you knew you could compete because there were so many that were going to need service?
The latter. GE is fully capable of servicing this fleet from a capability standpoint, but because of the number of units that were installed in a short period and the long lead times associated with the superalloy forgings that are a key part of extending the life of these in the turbine rotor section, we believed, and it's come to fruition, that no one entity can serve all the turbines that are out there that are coming to rotor end of life during the same relative time frame. And when I say same relative time frame, I'm saying like over a 5 to 7 year period.
Mm-hmm.
So the total count out there now is just south for the units types that we focus on for the 7Fs. It's between 800 and 900 for the ones that we serve. I won't go into detail about that, but the ones we serve between 8 to 900. And when you're talking about a 5 to 7 year period, that's a lot of forgings, a lot of shop time, and no one entity can serve all that.
Mm-hmm. I understand MD&A acquired an unfired GE 7FA.03 gas turbine and 7FH2 generator. Kevin, can you talk about why securing zero-hour components was critical to the success of the effort?
The key part of the 0-hour acquisition is you need to have something that is exactly as it was produced. So those parts, having not run, they're exactly as they left the machine shop and left the factory. So when you're doing your reverse engineering, you can see exactly what the parts are as they left the facility, the production facility. And that's what you want to ensure that you have the best final geometry, material properties, everything it needs to match how it's needed in the factory.
And what did the reverse engineering process involve, particularly for key components like wheels, and what were the biggest technical challenges along the way for reverse engineering?
There was a lot. You were looking at material development. special processing, like shop peening or coatings. You're looking at all your machining processes and how those were going to yield the correct final geometry. How you had to stagger it. It goes through multiple different machining operations and different processing, all in a different order. So we had to back into all that from those wheels, and it was there's a lot of very tight tolerance features within these parts that require a lot of precision measurement, a lot of investigation, and not just by one method, but by multiple methods. So that's the general basis of how difficult it was.
I don't know if you're willing to go into all the details, but I'm wondering what reverse engineering looks like. Do you take parts and put them on a table and scan them with lasers or use computers, or how does that process work?
Well, it goes into multiple levels. It's finding old components that we can do material testing from. So the material testing wasn't a function of using those 0-hour assets. It was other used parts that we could cut up and do material testing. As far as the actual parts how we're getting geometry, it's a vast combination. It's using everything from as simple as hand tools, right, where you can measure things real time and provide secondary measurements, to using CMM and blue light scanning, which is all the latest technologies in order to get geometry. And then it's also looking at the part itself and determining what special processing exists on the part, which a laser is not going to tell you, right? You have to physically be there touching the part with your hands and understanding what went into it. So it takes a lot of the expertise and the experience to understand what let's say a coated part looks like versus the shop part, what surface finishes are, all things that you're not going to get from a laser scan or from a CMM measurement.
Are there any legal things that you have to think about when it goes into reverse engineering something, or is that just fair game for anybody that has the money and wherewithal to do it?
Oh, we certainly have to work within patent laws and within the rules behind reverse engineering. So that was something that we worked closely with our own legal team to make sure that we were abiding by all the necessary restrictions, to make sure that everything we did was within the letter of the law.
There's a whole support staff that's tied to that, right? Whether it's legal or metallurgy support from Japan. We're owned by Mitsubishi, so they supported us with a lot of the testing and material analysis and things that, quite frankly, we maybe didn't know a whole lot about. We leaned on them for. So it really was a global effort up front, and now it's more of a MD&A moving forward. Now that we have the foundation.
Kevin, can you talk a little bit about why having detailed drawings was so important to this project?
In order for us to go to the different vendors and get items like forgings and that machining done or any special processing, we had to create all our own production prints. They obviously any of these companies can't work off alternate prints or anything like that. So MD&A has a whole detailed production process, including drawings, including special processing requirements, including material specifications, all that allow us to produce parts, from the raw material right up to the finished part.
So once you had the drawings made and the process effectively established, how did you go about building the supply chain?
Yeah, I mean, at that point, we're working through, I'll say, the global supply chain to determine who had the capability of producing these parts, right? As you say, the first part is making the drawings, but that doesn't mean that anybody can do this. This is very niche capability within the world, we'll say, in order to produce forgings or to machine the high alloys used within the turbine section. to hold the tolerances that we need, the tolerances and the surface finishes that we need. So we had to search the globe for vendors that were capable of doing that.
I imagine there's also challenges when it comes to finding companies that can produce high quality materials. I'm sure there are certain standards that you require, correct?
Exactly.
And what sort of quality control do you have as far as verifying sizes and tolerances and clearances? Do you rely on the company that's producing the materials and then second check it when it gets here, or is there like a MD&A person over wherever this happens to be being manufactured who is constantly checking these things?
Like a combination.
I think a heavy emphasis went into the first article inspection, right? And then we continue to apply scrutiny to the critical parts as an ongoing part of our quality control system. But Kev, would you agree that the for key components, a heavy emphasis and a lot of scrutiny was applied for the first particle inspection?
Yeah, well, there was a lot done upfront to ensure the first parts are correct, but that it didn't really remove a lot of the scrutiny. We still continue to have a high level of scrutiny on all parts, just given the criticality of them. And the rotor is obviously a very critical component within the turbine, so we scrutinize all parts very heavily.
And to answer your question directly, you are correct, right? So we lean on our vendors that we gain this experience and relationship with, but then we also check the parts when they show up in the shop. That's my role actually, right? Like the parts show up at the shop, they get physically checked and measured, and there's some additional machine time and stuff there. So there's multiple levels of quality checks on individual parts to make sure that they meet our standards.
We provide more scrutiny than other vendors might be doing for other similar parts. We're pushing quality as high as possible to ensure that the end product, we're not skimping on anything.
And Jason, you mentioned the fact that you're owned by Mitsubishi. Do you use them for manufacturing a lot of these parts, since they probably have the facilities to do it for their own equipment? Is that common?
No, I mean, Kevin might be able to speak to this a little bit more, but my understanding is we have a DOR with Mitsubishi. So we work on GE frames. They do not. So there is a delineation, but they did provide quite a bit of support up front.
Yeah, as far as the production goes, we looked within Mitsubishi and within external vendors, and then optimized the overall solution. So we've optimized our supply chain to achieve the best quality end result.
Mm-hmm. I'm assuming you probably also have multiple vendors so that if one can't deliver for some reason, you'd be able to go to somebody else and still have a backup plan?
Do that to the maximum extent possible.
Okay.
And continue to try and build out our supply chain for this.
And I think a key part of that also is there's the supply chain, but there's also our stocking strategy. We take into account lead times and what components are going to be replaced more frequently. And we include all that into a stocking strategy, which really, I think, positions MD&A really well to serve the marketplace.
Mm-hmm. I know lead times are a source of constant hand-wringing right now. Do you feel MD&A is in a position to deliver quickly during emergency situations or other unexpected circumstances?
I think we're uniquely positioned to serve the 7EA, 7FA customer base for emergent conditions as well as planned conditions. Mm-hmm. Albeit what you said is absolutely 100% true. The lead times on the 7FA turbine components, particularly the superalloys, is very long. So the customer base should expect those forgings to be consumed rather quickly and not rely on them to be available in short order, but instead should place POs several years out from when the actual need is.
Jason, can you talk a little bit about the role that the turbine generator repair facility in St. Louis played in performing the remaining life assessment and life extension work on the 7FA.03 rotor?
So the St. Louis shop is tasked with the hands-on portion of disassembling, unstacking, inspecting, measuring, NDEing, and restacking and assembling the rotors during the process. We use a couple different vendors in the shop for the specialized NDE requirements that come with these inspections, and it's all done there in St. Louis in that turbine generator repair facility. So alongside the steam turbine guys down at the other end of the shop and the generator guys and the valve guys and of course the high-speed balance facility, that's where our current gas turbine shop is also located.
Can you talk a little bit about the rotor rebuild and when you had all these newly manufactured components that you were bringing together? What sort of worries did you have going into that job?
The first thing is the made up, right? So like there's a fear that what you've done over the past 10 years is not going to line up, not going to be correct, not going to mate up to old run mating components. So pulling new parts out, like on the rotor that's stacked right now, there's a couple new wheels intermixed in the middle of the compressor with a bunch of old wheels. But we had the wheels, right? First, we had the capabilities to manufacture the wheels. We had them in St. Louis when we needed them. They made it up to the old wheels perfectly as expected and designed. And it allows us the freedom of grabbing old repaired round parts if available and necessary to save cost and time for customers. Or when the need arises, we have those components sitting in St. Louis, and it's easy to put, get with Fernandes and grab one of those parts out of storage to use in the rotor. It's a matter of a conversation versus jumping through hoops to try and get it done.
Why are having seed rotors so important to your strategy?
One of the approaches that we've considered that's important to all power generation customers is downtime. So we're positioning ourselves where we aim to always have seed rotors in place to provide as an exchange. So the downtime for customers that come our way for rotor life extensions only have downtime associated with disassembly, putting the turbine on a half shell, removing the rotor, putting it on stands, taking the rotor that we're providing, putting it into the unit, reassembly is startup. So we're trying to take an approach that limits operational downtime for the customer base. And then when the rotor that comes out, we take that in and put it back into rotation as part of our seed rotor program.
Which is a program, by the way, that is already running on the 7FH2 generator side. So MD&A already has the experience to build that program. We're just in the process of it.
Okay. What would you say to a customer who may be looking at maintenance 5 years in the future, thinking, oh, I've got time, there's nothing to worry about, I don't need to get anxious here?
I think that's what Dave already talked about, right? It's just the lead time of these components. If you know you need a rotor in 3 to 5 years, it starts getting built today, right? You're starting the production of those components today. If you don't have that slot opened, if you find that's a planned outage or a planned replacement. And if you find it out in your urgent method, you need to either find somebody that has it already built, as Dave was saying, have those components ready to go, or you're going to be sitting with a ton of downtime. So it's the key part there is just these are not parts that get built in a week. These are parts that take multiple years to be produced, to be assembled, in order to achieve the level of quality that you want.
And some of the customers are aware of that, right? Some larger customers have their own seed rotor programs where they're leapfrogging 7Fs through their fleet and trying to maintain hours and factory fire starts and all that stuff, right? So we're just we're just poising ourselves to support those that either have already used up their seed rotors in a forced outage, or those individuals that haven't done the necessary planning for when that forced outage comes, or they have a cracked T1 wheel and realize that it does take a few years to manufacture that wheel from start to finish.
And there's two things that really are, honestly, I'll just say it like I'm thinking it, should make a customer nervous. Actually, there's three. The number of units that are out there that we already talked about. There's hundreds of these. They're operating, and with the trajectory, with the server boom, they're going to be running for a long time still. The other thing is what Kevin already alluded to, which is the lead time for some of these critical components to extend the rotor life. And the third thing is there is a very limited number of shops in the world that can service these large 7FA gas turbines. It takes specialized equipment, specialized capabilities to do it, and there's very few in the world that can do it. So the other thing that should and is making the customer base nervous about how they're going to extend their rotors, these 7FA rotors, is shop time. So the number of units coupled with the long lead time parts coupled with limited shop space in the world are the three prongs which should give customers some angst and make it a high priority to get out in front of their rotor life extension needs.
Mm-hmm. Can you walk through a typical project for listeners and how that project or process might proceed?
So the good thing is we've built our inventory plan to where we have the most likely replaced capital parts in hand, right? So we have a plan for the what ifs. Once the job's been awarded, and let's say it's just the end of life, or we're going to have to get through an end of life, and it's not just a straight, exchange or anything like that. The rotor would come into the shop, and we would do our visual and dimensional inspections. We would request information from the customer, run times, hours, starts, and any issues, so that I know when I get to the unstack if I'm going to run into issues unstacking. The hours and all that stuff, the unit run data, that's going to be sent over to the engineering group. They'll start looking through that while I get into taking the rotor apart. And it's pretty well like any other inspection, right? We're going to do visuals, we'll do the compressor gap checks, we'll do the runouts, the dimensional measurements, journals, packing or steel lands and everything else. And then we'll disassemble the rotor, unstack the rotor, we'll blast clean everything. Then we'll do our perfory NDE and then our specialized NDE. So we have a vendor that we partnership with. They'll come to the shop. They'll do their specialized NDE, their eddy curves, their volumetric phase array inspections, their UT inspections on the studs. And then based off of all that dimensional data, NDE data, and then runtime data, we'll make decisions on what parts can run, what parts have additional life in them, what parts are essentially dead or fall out. And then we look to our inventory stock and make sure we have those parts. And if we don't, then we go out and we source those parts. Luckily, we have the mass majority of parts that we need, at least the long lead time parts. So we'll pull those out of storage, working with the parts team, David and Kevin, making sure that they know bill of materials, what's going where. And then we'll repair, patching, what have you, replace blades, whatever needs to be done to the individual components to make them serviceable. Put them back together with new components, and then we'll recertify the unit rotor after balance for a new life. Put a new sticker on it, so to speak, and then it will either sit or go right back to the customer to be installed. If it's part of an exchange, it would then sit until the next customer calls up and says, I got an issue, and we say we got a rotor that will fit that pocket. Let's do it again. And hopefully we get a few of these in rotation like we're doing on the generator side, so that we always have. That's the goal, is to always have a seed rotor waiting, so that if somebody calls, it's quick. It's not that a few month process where somebody's sitting there waiting, wondering if we got the right parts we need for the rotor. There's already one sitting there built and ready to go. It makes it easy.
So in most cases, you would say, you're getting their parts and you're sending them another refurbished rotor that's ready to go. And so there's no delay waiting for you to rebuild this one that came out of their machine.
That is the goal, yes, sir. And the exchange is certainly tied to a lot of those transactions. We don't want to give up our seed rotor assets without having another seed rotor asset in its place, because they're that limited in the world.
I'm guessing the time to refurbishment varies based on many factors, but is there kind of a guideline of how many hours you can operate for these 7FA rotors?
7FA rotor end of life is 144,000 hours. 7EA, I think it's 200,000 hours, maybe 5,000 starts.
Yep, both are 5,000.
And then there's lots of customers that, especially on the EA side, that are running well beyond that now. And the EA is a lot easier to produce and manufacture and more readily available.
Yeah, and what Jason referenced in terms of limitations, that's dictated by the OEM, not us. It's they have a technical information letter out there that's sent to all their customers. It's TIL 1576, I believe, that outlines that and dictates that. And the insurance companies know about it. So.
Mm-hmm. All right. Well, thank you, gentlemen, for joining me on the podcast. Again, for listeners, I've been speaking with Dave Fernandes, MD&A's Gas Turbine Program Manager, Jason Wheeler, MD&A's Gas Turbine Rotor Repairs General Manager, and Kevin Roy, MD&A's Principal Engineer for Parts. Thanks for your time. It's been a pleasure speaking with you.